Whenever the input of a function f increases by 1, the output increases by 5. Which of these equations could define f? So to do some examples, let's try 1 and 2 for our inputs. So this would be 3 times 1 plus 5, which equals 3 plus 5, and our answer would be 8. Now if we increase the input by 1, we have 3 times 2 plus 5, which is 6 plus 5, and our answer is 8. We did not increase by 5, we increased by 3. So A is not correct. Now on B, if we try it, 5 times 1 plus 3 becomes 5 plus 3, which is 8. If we try to increase our input by 1, we get 5 times 2 plus 3. That becomes 10 plus 3, which is 13. We increased from 8 to 13 when we increased our input from 1 to 2. So B appears to be correct. Let's check C. 5 to the power of 1 is 5, and 5 to the power of 2 is 25. Here we increased by 20, so it's not C. And finally, on D, 1 to the power of 5 is 1, but 2 to the power of 5, 2, 4, 8, 16, 32. We increased our input by 1, but we increased our output by 31. So it's not D. The answer is B, and the reason is because our input is being multiplied by 5, so every time you increase the input by 1, you're getting another 5. If you have any questions about how I solved this practice problem, please use class time to ask for clarification before the end of Unit 5 test on Monday, March 25th. The function f is defined by f of x equals 2 to the power of x. Which of the following statements is true about the values of f? Select all that apply. A says when the input increases by 1, the value of f increases by 2. B says when the input x increases by 1, the value of f increases by a factor of 2. So you are not you're not adding 2 each time. You are increasing the exponent, which makes you multiply by 2 an additional time. So that would be increasing by a factor of 2, not increasing by 2. And a simple explanation for this, 2 squared equals 4, but 2 cubed equals 8. We did not increase by 2, we increased by a factor of 2. C says when the input x increases by 3, the value of f increases by 8. But D says when the input x increases by 3, the value of f increases by a factor of 8. We can test that. 2 squared equals 4. But 2 to the power of 5 equals 32. We did not increase by 8, we increased by a factor of 8. So D is the correct choice. And E says when the input x increases by 4, the value of f increases by a factor of 4. So we can try that. 2 to the power of 1 equals 2. 2 to the power of 5 equals 32. This did not increase by a factor of 4. This increased by a factor of 16. So E is not correct. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification before the end of Unit 5 test on Monday, March 25th. The two lines on the coordinate plane are graphs of functions f and g. Use the graph to explain why the value of f increases by 2 each time the input x increases by 1. So these are linear functions. So what we want to do is look at the slope. We can see that if we started at the origin, we could go over to x equals 1 and up to y equals 2. Then we can go over to x equals 2 and we can go up to y equals 4. We see this consistent pattern which tells us the slope of f of x equals 2. Number 2, use the graph to explain why the value of g increases by 2 each time the input x increases by 1. Well, you can see that f and g are parallel lines. Since f and g are parallel, they have the same slope, which is 2. So this is why every time x increases by 1, y increases by 2. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification before the end of Unit 5 test on Monday, March 25th. The function h is given by h of x equals 5 to the power of x. Number 1, find the quotient h of x plus 2 divided by h of x. So the h of x's cancel each other out, leaving 2, and 5 squared equals 25. What does this tell you about how the value of h changes when the input is increased by 2? The value of h is multiplied by 25. Number 3. Find the quotient h of x plus 3 divided by h of x. Again, the h of x's cancel each other out, and we just have 3. So 5 to the power of 3 equals 125. Number 4. What does this tell you about how the value of h changes when the input is increased by 3? The value of h is multiplied by 125. The reason this happens is that no matter what number I put in for x and I get the value, if I increase that by 2, then that means I am multiplying it by 5 and then by 5 again, which overall multiplies by 25. And in number 3, no matter what value I've put in for x, and I have found my value of h of x, if I increase my exponent by 3, then I'm going to take that value, multiply it by 5, multiply it by 5 a second time, and then multiply it by 5 a third time. And that would be an increase of multiplying by 125. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification before the end of Unit 5 test on Monday, March 25th. A credit card charges a 14% annual nominal interest rate and has a balance of $500. If no payments are made and interest is compounded quarterly, which expression could be used to calculate the account balance in dollars in 3 years? A compounds annually, so that cannot be correct. B compounds quarterly, but only 3 times. So that's incorrect. C correctly compounds quarterly by dividing the nominal by 4, and because there are 4 quarters in a year times 3 years, it compounds 12 times. So C is the correct way to represent this. And D correctly compounds quarterly, but it compounds for 48 quarters, which would be 12 years. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification before the end of Unit 5 test on Monday, March 25th. Here are equations that define four linear functions. For each function, write a verbal description of what is done to the input to get the output, and then write the inverse function. On number 1, 4 is subtracted from the input. The inverse would be x equals a of x plus 4, because we would add 4 to each side to get x by itself. In number 2, the input is multiplied by 2, then 4 is subtracted. The inverse, we would add 4 to both sides and then divide by 2. So x equals b of x plus 4 divided by 2. Number 3. 4 is subtracted from the input, then multiplied by 2. The inverse, we would need to divide both sides by 2, then add 4. So x would equal c of x divided by 2, and then add 4. And finally, number 4, The input is divided by 4. The inverse would require us to multiply both sides by 4. So x would equal d of x times 4. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification before the end of Unit 5 test on Monday, March 25th. The average price of a gallon of regular gasoline in 2016 was $2.14. In 2017, the average price was $2.42 a gallon, an increase of 13%. At that rate, what will the average price of gasoline be in 2020? So we can use the price in 2017, which is $2.42. We will multiply that by 1.13. The 1 represents maintaining the $2.42. The 0.13 represents increasing it by 13%. Now we want to go from 2017 to 2020, so our exponent needs to be 3. We do the exponent first. We have $2.42 times, on a calculator, we're going to do 1.13 to the power of 3. This gives us our new compounding rate of 1.44. Now we multiply that by the original $2.42, and because this is money, we will round our answer to $3.49. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification before the end of Unit 5 test on Monday, March 25th. Here are the graphs of 3 functions. Which of these functions decays the most quickly? Looking at the graph, we see that the green line, function z, drops the quickest or the most steep. So function z decays most quickly. Then they ask which one decays the least quickly. That would be the line on top that is the least steep. So function x, the red line, decays the least quickly. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification before the end of Unit 5 test on Monday, March 25th. The table shows the height of a ball after different numbers of bounces. Number 1. Can the height h in centimeters after n bounces be modeled accurately by a linear function? Explain your reasoning. So if we look, we subtract 22, then we subtract 15, then we subtract 11, then we subtract 9. So this is not a linear function because we are subtracting very different numbers. Number 2, can the height h after n bounces be modeled accurately by an exponential function? To determine this, we need to take each second point and divide it by the first. So 61 divided by 83 is 0.73. Next, we would do 46 divided by 61. That's approximately 0.75. Next, we could do 35 divided by 46. And that's 0.76. And finally, we could do 26 divided by 35. And that is 0.74. So we can see that we have almost identical growth factors. It appears we are multiplying by about 0.74 each time. So, yes, the factor is approximately 0.74. So now if we wanted to know, it tells us to create a model for the height of the ball. Well, we would need to know where the ball was when it was dropped. So normally you would take h of 0 and multiply it by 0.74 to get h of 1, which was 83. So now to find h of 0, we're going to divide 83 by 0.74. And this equals approximately 112. So if I wanted to create a model, I would say approximately, let's say, h of n equals 112 times 0.74 to the power of n. Number 4 says use your model to estimate the height the ball was dropped from. Well, that would be the number that's by itself. So that would be 112 centimeters. And number 5, use your model to estimate how many bounces it takes before the rebound height is less than 10 centimeters. So we know that at 5, it's still 26. So if we tried it keeps getting smaller, so let's move at least 2 spots. And let's say 112 times 0.74 to the 7th power. This would be 112 times, we're going to do the exponent part first, 0.74 to the 7th power, and that is about 0.12. And we multiply that by the original 112, and we're at 13.6. So we're going to need to go even bigger. Let's try 112 times 0.74 to the 8th power. This would be 112 times 0.74 to the power of 8 is approximately 0.09. And if we multiply that by the original 112, we are at 10.0. So depending on which of these we use, because we were estimating a growth factor of 0.74, low end is 0.73, high end is 0.76. So we could pick anything in between there. At 8, assuming we dropped it from 112. We are pretty much right on 10. So if you said 8 or 9 bounces, you would be correct, because this could vary a little bit depending on what we decided to use for our growth factor and what that gave us for a drop height. So 8 bounces or 9 bounces is what it would take. If you have any questions about how I answered this practice problem, please use class time to ask for further clarification before the end of Unit 5 test on Monday, March 25th. I used a computer simulation to roll number cubes and count how many rolls it took before all of the cubes came up sixes. Here is a table showing her results. Would a linear or exponential function be appropriate for modeling the relationship between D and R? Explain how you know. So the first thing we want to look at is, are we adding the same amount each time? That would make it linear. To go from 5 to 31, we add 26. To go from 31 to 143, we add 112. And to go from 143 to 788, we add 645. So we are clearly not adding the same amount each time. Next, we can see what our factor is. You take the second y value, such as 31, and divide it by the first y value, 5. 31 divided by 5 equals 6.2. So we would say we multiplied by 6.2. Now let's try 143 divided by 31. This equals 4.6. So now we're multiplying by 4.6. And lastly, divide 788 by 143. And you get approximately 5.5. So neither function is perfect. We're clearly not adding the same amount each time, and we're clearly not multiplying by the same amount each time. But we are much closer to multiplying by the same factor than we are to adding the same amount each time. So an exponential function because we're closer to multiplying by the same factor then adding by the same. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification before the end of unit test on Monday, March 25th. A ramp is 2 meters long. Priya wants to investigate how the distance a basketball rolls is related to the location on the ramp where it is released. Recommend a way Priya can gather data to help understand this relationship. Priya can mark equal distances up the ramp, such as quarter meters or half meters. Then track how far the ball rolls from each mark. So she could start the ball half a meter up the ramp, let it roll until it stops, write down the distance. Then she could start the ball rolling from 1 meter up the ramp, let it go until it stops, and measure the distance. And then she could put these into a table and she could see what kind of relationship there was between the height up the ramp and the distance the ball rolled. And then she could look for things like a linear relationship or an exponential relationship or some other type of relationship. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification before the end of unit test on Monday, March 25th. For each of the functions f, g, h, p, and q, the domain is 0 is less than or equal to x is less than or equal to 100. For which functions is the average rate of change a good measure of how the function changes for this domain? Select all that apply. So as we look at the choices, f of x equals x plus 2. This is a linear function. The rate of change will be consistent forever. So even though the domain is 0 to 100, the rate of change is a good measure. Choice B. G of x equals 2 to the power of x. This is an exponential function. The rate of change for an exponential function varies greatly between the beginning of the domain and the end of the domain. So, rate of change is not a good way to measure how the function changes over a domain as big as 0 to 100. Choice C. H of x equals 111 times x minus 23. This is another linear function. Again, the rate of change is consistent throughout, so even a domain of 0 to 100 is represented well by the rate of change. Choice D. P of x equals 50,000 times 3 to the power of x. This is another exponential function. And exponential function rates of change vary greatly between 0 and 100. So D is not a good choice to be described by the average rate of change. And finally, choice E, Q of x equals 87.5. This is a horizontal line. The rate of change would be 0, and it would be 0 forever. So this is described well by the rate of change because the rate of change never differs. It will be a horizontal line to infinity in both directions. If you have any questions about how I solved this practice problem or any of the practice problems from lessons 20 and 21, please use class time to ask for clarification before the end of unit test on Monday, March 25th.